Next, how to enable the assertion and coverage logic. The Accelera standard OVL consists of two types of logic. First one is assertion logic, second one is coverage logic. Okay, so assert on means assert on activates assertion logic, cover on activates coverage logic. Cover on, assert on, those are all some. So how we can limit checkers reporting? Limits on the number of times assertion violations and captured coverage points are reported are controlled by following global variables. We have to use some global variables. Look at there. Tick OVL. These are all compiled directives, right? Tick OVL max report error. If you are defining this one, then what will happen? It will discontinues reporting a checker's association violation if the number of times the checker has reported. If the number of times the checker has reported one or more violation reaches this limit. Next, tick OVL max report cover point. Here we can mention what is the maximum report cover point. What it will do, once it reaches that maximum cover point value, then it will discontinues reporting a checker's cover points if the number of times the checker has reported one or more cover points reach OVL. Okay, Verilog assertion syntax format is what? So this is what the assertion syntax. So what we have to do, assertion instantiation, you know, assertion instantiation, assertion identifier. Look at there. Okay, so for in that OVL library all those assertions will be there. In our design we have to instantiate the assertions you want to implement in your design. Assertion underscore instantiation assert identifier. So here you can do the parameter value assignment, like we know the two types of parameter overriding, right? Def param and parameter overriding by instantiation. Okay, two things are there. So parameter value assignment, by using this also you can do. And this parameter value assignment should be like this. So we have to mention the severity level and the property level and the message and coverage level. These are all the four things we can override in our local instantiated assertions. Okay, and then module instance. What is that module instance? We have to mention the name of the instance. Okay, and in that assertions definitely there will be module connections, so we have to do that connections. The first assertion we are going to see here is the assert always. Okay, assert always assertion checker checks the single bit expression, that is test expression, at each rising edge of the clock to verify the expression evaluates to true. Okay, for example, look at there. We are having assert always block. Okay, so for that we are giving the test expression as an input and two global inputs we have already discussed, that is global clock and global reset. Okay, now look at there the syntax. This is an as a module name, assert always. Okay, here instance name we are mentioning here, instance name, and these are all the parameters we are going to override. Okay, and the ports of this assert always module is clock, reset, test expression. I think one more type, assert always on edge. So this is an next assertion. Okay, as we have discussed, assert always this is assert always on edge. Okay, so we can easily remember on edge means we can mention whether it is related to positive edge or a negative edge and all. Okay, now look at there. Last we have previous assertion is one cycle, here two cycle assertion. We'll see how it is differs. Okay, now the syntax, if you come to syntax what it's the same, module name, module instance name and port list, then parameter overriding.